what we do that, to improve that, we use these skip connections. Okay, so this is your CNN or SCN network, and these are different layers. So after the final layer, let's say you make this prediction, the heat map for each category you have in your data set, right? So in this case, you'll have to perform some kind of upsampling, because this is, let's say, 2 cross 2 or 4 cross 4. This has to match with the original input image, right? So for example, you have to upsample by 32 times. All right. Then what you do, you take on those features again, and you upsample by 2 times, and then use features from the previous layer prior to this. Okay, so these are the features. And since these are now upsampled, so let's say this is 1 cross 1. If you upsample by 2 times, it will become 2 cross 2, right? And these features are already 2 cross 2. Then you can just add these features, or you can concatenate these features. There are different ways to integrate these. And then again, you make this prediction, like what kind of segmentation heat map you will have. And in this case, since you have already upsampled 2 times, you only need to upsample 16 times. Okay, considering like the total compression was 32 times from input image to the output image. Okay, so and you can assume that if this is 1 cross 1, your input image is 32 cross 32. All right, so you make this prediction. Then again, you can have more skip connections from earlier layers. And again, you will upsample these features. Again, let's say you upsample twice. So this will become 4 cross 4. And these features are already 4 cross 4. You take these features, you concat or you can add, both works perfectly fine. And then again, make predictions. In this case, it's just 8 times upsample. So in a way, you are making prediction for semantic segmentation, and you're making multiple predictions. So this is kind of a prediction at different scales, but all are actually trying to make the same prediction where cat is present and the segmentation boundary for that cat. So your network will look something like this. Okay, that's going to be the output, and you will have the segmentation ground truth for each image. And what you will do is, for each class category, you will predict one heat map. And from the ground truth, you can extract like the heat map for that particular category and compute the loss. For example, if you have 20 different classes, you can have 20 different heat maps like S channels, where each channel corresponds to one of the class category. Now, let's quickly look at like some of the visualizations for the results you can get from these kind of predictions. Since this is like a very crude prediction, we didn't have any kind of spatial information here, right, in pool 5. So this is the result which we have. And you can see that you don't have any fine boundaries at all, but you just have rough estimation of like, okay, this is a person and this is a cycle. Okay, this is a cycle, this is a person. But if you start using features from prior layers, which have like more spatial correspondence, then you can see your performance is actually improving. And if you move further, it keeps improving. Okay, basically, if you use like maybe this layer as well, it will improve further, but again, your computational cost is actually improving a lot. And this was the actual ground truth, which says that a green pixel is a cycle or bicycle, and the orange or this other color is for person. Okay, so this is the semantic segmentation ground truth, and these 3 predictions might come from these 3 different channels. Right. So few things here, like I think I introduced some of these we have already covered. So skip connection, that's a very important concept. You will see like if you have to make some kind of dense prediction task, whether in images or videos. So dense prediction is again like for each pixel, you have to say something what is happening there. So for those dense prediction tasks, these skip connections are very useful. All right. So the skip connections, the idea is you actually pass your features from different layers of your encoder to the decoder part. If you try to visualize this, this part is actually your decoder. And the only difference between this decoder and the decoder used for autoencoders is, in this case, you're trying to make multiple predictions. But you don't have to do that if you think about this. You can just ignore this one and ignore this one. and just keep upsampling, right? And keep adding these features and just make prediction at the end. Then it will be more close to your traditional autoencoder. The only difference will be you will have these skip connections. Okay. So one thing which is important, how you are combining these features. As I said, you can add these features, which is also fine. You can just concatenate these features that will increase the number of channels you have in your decoder. So slightly it will have more computational cost. You might get slight better improvement as well in terms of performance. So those are two variants. And of course, there can be like many different ways to do fusion, but you don't have to like go through those. These two are, I think, sufficient, at least for some reasonable results.